Section 6.3 is one of my favorites. I remember this in high school, learning about the elimination method, and it was just so cool to learn about this very slick way to solve these systems. You've learned how to solve them by graphing, and then you learned how to solve them by substitution, by taking one of them and putting that into the other equation. We're going to learn this other way called elimination. So let's move forward. All right, before we get to this elimination method, let's look at this silly screen here. If we had two separate balances and we had a grumpy cat balanced with 12-pound weight, and then we had a second balance where we had a happy dog balanced with 16 pounds, I think you would agree that we could do the following. We could get a third big balance. We could get a third big balance and do the following. We could take those weights from the right side and put them on the right side of our new balance, our new bigger balance here, put them on the right side. But then what do we have to put on this left side to keep everything balanced? Hey, you bet, we need to move the animals over there. Put him over there and put him over there. And there we are. And the new balance is balanced. Now you might be wondering, what on earth is Mr. White talking about? Well, you know what? We have 28 pounds. We could add those together on the right side, and then we kind of add these guys together and we probably get a mess, but we could put the two animals together on the same side, which is kind of like adding them together. And here we see two equations. We got a red one and a blue one, and of course equations have a left side and a right side, and earlier in the year we talked about these as being like on a scale. So here we have the red left side and the red right side, and now we have the blue equation on the left and the right. Now you can probably guess we're going to create a third scale and actually lump the left sides together and lump the right sides together. So let's take a look at what that looks like. There they are, all lumped together. Now what do you notice? I've put the x's and y's next to each other over here. So what do you notice happens? What happens with those y terms? They add to 0. They cancel each other. They eliminate. This is called the elimination method for a reason. All right, and you'll see why here in a second. Now on the top, we have 6x. And on the right side, we have negative 18. So let's go to the next slide where that's all laid out. There it is. The 6x and the negative 18 is the same thing as writing 6x equals negative 18. Divide both sides by 6, just like solving an equation now, because the y has been eliminated, and you get x equals 3. X equals 3. Now, remember, we're trying to solve for the point of the intersection of these two lines. We just discovered that the x value is 3. Now, to get the y value, just like in the last section, you got to plug and chug out the answer. So let's do that. Negative 3 minus 2y equals negative 19. I got that from right there. All right, and I put negative 3 in for x. We add 3 to both sides. We get negative 16 equals negative 2y. Y equals 8. 8, and there it is. The point of intersection of these two lines is negative 3, 8. Now, let's do a problem without all the scales in the way, and you will see how easy this is. All right, Arnold's in the picture here because he's going to help me eliminate one of the variables here. All right, with the elimination method, you will be adding the two equations together. So let's add them up. 3x plus 1x is 4x. These guys add up to 0. Now I'm going to erase that because I don't want the 0 to be in the way. But we understand that that's what happened. Bring down the equal sign, keep everything lined up. 4x equals 8. In your head, you can divide by 4 on both sides, and you see x is 2. Oh my goodness, that was really easy. 2 comma something. Now to figure out the something, come over here, x plus 4y equals negative 2, and put that 2 in for x. So 2 plus 4y equals negative 2, minus 2 on both sides. You see 4y is negative 4. So y equals negative 1. And I plug that in there. There's my answer. 2, negative 1. This is called the elimination method. And this particular problem was all set up for you because when you add the two equations together, they add up to 0 right here. So you need to make sure the terms are all lined up. You're going to eliminate one of the variables and solve for the other. Substitute the value into the original equations to solve for the second half of the answer. Don't forget to write your answer as an ordered pair. All right, I would like you to pause the video at this point, and I'd like you to try this on your own on a piece of paper and see if you can get the right answer, and then I'll quickly work through it. So pause it in 3, 2, 1. All right, here we go. Add them up. You get 5x equals 20. X equals 4. Plug that in. 4 comma something. To figure out the something, you got to plug in for x. 3 times x plus 3 times y is 15. Plugging in for x, you get 3 times 4 is 12. 12 plus 3y is 15. 3y equals 3 when you subtract 12 on both sides. And you get y equals 1. Plug that in, 4 comma 1. So raise your hand if you got that right. Hopefully your hand is in the air. Good job. All right, now we're going to look at a thing called transformations because it's not always this easy, of course. They don't always add up to 0. So let's move on. You heard me say the word transformation. Maybe you were thinking about transformers, and that's kind of what we're going to do here. We're going to do a transformation. We notice that the y's don't add up to 0 this time, but we would really like them to, and boy, if only this were a minus sign. If this had been a minus sign, we would have been fine. Well, we can do a cool little trick. We can multiply one of the equations, or both, by a number. And I'm going to choose negative 1 because what happens is it changes all the signs on all the numbers on the second. So I'm just going to go ahead and rewrite the system. Normally, I would probably just change all the signs and move on with my life. So when you multiply negative 2 by negative 1, you get positive 2x. Then you get negative 4y, and then you get negative 8. Notice I changed the signs on all of them. All right, so I multiplied by negative 1. Now we add them up. We get 5x equals 10. X equals 2. 2 comma something. So then we plug that 2 in up top somewhere. 6 plus 4y equals 18. 4y equals 12. Y equals 3. So plug that in. Y equals 3. There's your answer. So this is a simple transformation. Basically, I just had to change all the signs on one of the equations, and then I could have added it up. All right, let's move on. So we look at this question. I see the transformer there, so we must have to do a transformation again, and unfortunately changing the signs on one of them will not cause a 0 to happen, because that's our goal here, is to get one of these guys to add up to 0 when you add them up. So we're going to have to do a different transformation, and instead of multiplying by negative 1, let me delete this away. Instead of multiplying by negative 1, we're going to pick a different number. And you have to choose, and this is where some students have some troubles, is you have to come up with the right number. I'm going to multiply the second by 2. Now, where did I get that? Well, I'm looking ahead, and I'm thinking, you know, if this were negative 2x, and the first one is positive 2x right here, if I could turn that into that, if I could transform it into that, it will add up to 0. So that's my goal here, is to get the stuff to add up to 0. So I'm going to do a transformation with the red one. I'm going to multiply the second by 2. Now, whenever you multiply by 2, you have to multiply everything. So the 3 becomes a 6, and the negative 12 becomes a negative 24. Now, the first one is going to remain untouched. I'm going to not touch that one with a transformation. And now I add everything up. You see how the 0 happens there? So that's good. The 0 happens, and we add this up. 7y equals negative 21. Y equals negative 3. So this is the first problem, I think, where we actually solve for the y first. Make sure you put that, and it's time to continue moving on and to plug in. If you plug in negative 3 in for y somewhere, I'm going to go back to that first equation. You see right here, 2x plus negative 3 is 3. Add 3 on both sides. You don't get 0, you get 6. So 2x equals 6, x equals 3. 3 is the answer there. So that was involving a single transformation, and we had to do this transformation so that the 0 would happen. Remember, look right here. You see how these added up to 0 after our transformation? That was our goal, is to get something to eliminate. This is called the elimination method, so that one of these guys gets eliminated. All right, let's move on to a double transformation where we're going to bring in another transformer into the picture. All right, when we take a look at this problem, we notice that it's not going to add up to 0, certainly, so just changing the signs ain't going to do it. So maybe we need to do a transformation. But here's the other thing, is that turning a 2 into a 5 so that adds up to 0 isn't exactly easy. Or turning a 2 into a negative 3 so that adds up to 0 isn't exactly easy. So we're going to have to do a double transformation, and showing your work and laying out your transformations is really important here. So we're going to take a look at these equations and ask ourselves, what would it take to add these two together? Well, if we had maybe positive 6 and negative 6y would do it, or maybe 10 and negative 10 would do it also. All right, so let's set a goal to have 10x and negative 10x, and they will add up to 0. So we're going to have this red equation, and we're going to have the blue equation here. So to do the red equation, it looks like I have to multiply by 5 to get to 10x. 2 turns into a 10 by multiplying by 5, so I got to multiply everything by 5. 15y equals 40. Now I'm going to switch to blue. On the blue equation, how do you go from negative 5 to negative 10 through multiplication? It would be a transformation of times by 2. So it looks like I got to double everything. 4y equals negative 2. Now that I've done my transformation, I can go ahead and add these equations together. Now, of course, these guys add up, so that goes away. 19y equals negative 38. Divide by 19 on both sides. You see y equals negative 2. Well, that's nice. It came out beautifully. Negative 2. And then to get the first part of the answer, remember you plug that negative 2 back in for y on one of these. So either one will work. I'm going to plug it in right here. So here we have 2x plus 3 times negative 2 equals 8. I'm going to add 6 on both sides because that's a negative 6. And I get 2x equals 14. X equals 7. Plug that guy in right there, and you've got the answer, 7, negative 2. These are the hardest problems where you have a double transformation, and you have to choose the 5 and the 2. Remember what your goal is, because if you don't understand your goal, you're not going to come up with the right transformations. Your goal is to transform these equations so that something adds up to 0. I set my goal to turn these guys into a 10x and a negative 10x so that they would add up to 0, and then all was good with the world. Make sure that you do all the multiplication on everything. So I multiplied the 3 by 5 and the 8. Common mistake is to forget to multiply the 8 by 5. Here I decided to double the second one, so I doubled everything, including the negative 1 became negative 2. Solve it all out. Hopefully you get a nice round answer. If you don't, you probably did something wrong. Most of these come out even when you're working the homework. All right, good luck with the homework. Let me know if you have any questions.